All right, well, welcome everyone. I'm Jeff Bigham. I'm going to be your instructor today and for the whole semester for crowd computing. I've got a lot of stuff going on over here, so I'm trying to try out recording these lectures so that I can put them online for you all. So if I am seeming a little preoccupied with messing with this stuff, that's what I'm doing. Anyway, welcome to crowd computing. So it's really exciting to teach this class. This is probably my third or fourth time teaching this class over the last few years. And what we think of as crowd computing has really changed a lot over even that time period. So when I first started working in this space, we used to think of kind of crowd computing more like Mechanical Turk or getting data labeled. And now we're seeing this really interesting confluence of trends around not just kind of this crowd labor on very simple microtask data labeling types of things, but we're seeing intersections now with future of work, like what will work become. We're seeing intersections with things like the gig economy, the freelance economy. So a few years ago, I never would have thought that something like Uber and something like getting my data labeled for my AI system to work better would have similarities, but now we're starting to realize that actually maybe it's part of this connected growing trend. And so I'm really excited to teach it, and I'm glad that you're here. So I'm going to get started with just some kind of quick introduction to what crowd computing is, what I see it as it being, and some examples of kind of cool stuff that we've been able to do with kind of bringing crowds, so people out on the web, into our computing systems. So welcome to crowd computing. I am your host, Jeff Bigham. Let's go into presentation mode. All right. So this is me. I am a professor in the HCII and in the LTI, that's the Human Computer Interaction Institute and the Language Technologies Institute here in the School of Computer Science. My background started out in artificial intelligence back in graduate school. Started trying to build intelligent systems. And eventually I found my way to building intelligent systems for people with disabilities. So how do we bring all of this great stuff that AI is doing to the real benefit and impact of people with disabilities? And I pretty quickly was discouraged by that because it turns out that, although there's been amazing progress, we're still pretty much at the early stages of what we can do, especially 10 years ago and even today. And so because of that, I started looking at what we could do with not just machine intelligence, but also by bringing in the intelligence of people from out on the web into our systems to make them work better. And that's how I kind of got here. So I started out in AI, wanted to build applications that would be really useful to people, and found that we can do a lot more by bringing in not just artificial intelligence, but also human intelligence. And so that's kind of me. But I thought that we could go to About You. And so I've set up a shout key. Anyone heard of shoutkey.com? Yeah, a few people? Super useful. So all it is a URL kind of shortener, but it's ephemeral, which means a day from now or maybe a few hours from now, this link won't work anymore. But the nice thing is you can go to these very understandable words. So shoutkey.com/lean. If you go there, maybe not everyone has a device. I encourage you to bring devices in the future. I'm kind of the outlier in my professor peers and actually encouraging you to bring devices to class. You'll be able to fill out a little form that will tell me a little bit about you and tell all of you a little about you. While you do that, I'll take a couple pictures of you. If you want to look up and smile, if you're on this side of the room. Yeah, everybody this side of the room. Okay. All right. Now, kind of like middle of the room. Person in the back, wave. Okay. All right. Now, this side of the room. Person in the back gets to get double billing. Okay. Right. Okay. So, while you are filling that out, shoutkey.com/lean. I'm going to be trying really hard to do something very quick. Hopefully it works. No. You get to see random pictures I take, but they're not up yet. Your pictures are not up yet. Okay. We have 21 responses already. How many people? There's more than that in here. wait a little bit longer. 23 responses. 4 responses. Backing up, it says 7 photos left, so be here in a second. 30 responses, that's getting pretty close. How many people? About 40 people, I think. 40 people registered, 32 responses. Oh, they're all getting ready to go. That's kind of nice. All right, 32 responses. Anybody else? Right on the edge of responding? No? Okay. So here's all your IDs and things, which will be great. But here we get a quick breakdown of some of the things that are happening. So maybe not surprisingly, there's maybe a few more people from computer science and other things, but this is pretty awesome. There's all these different majors. We have chemistry. Well, okay, so different ways of saying yes. You know, this is one of these unfortunately still difficult problems of naming things. Actually, one of the hardest problems in computer science, it turns out. Business administration. What's BCSA? What is that? Brain cognitive science? A? No? Okay.
Bachelor of Computer Science and Art.
Oh, and art. Oh, very cool. Very cool. And art. Got lots of cool stuff. All right, have you used a crowdsourcing platform before? So most people know. I will convince you over the course of this semester that you probably have used a crowdsourcing platform. Maybe not one that's active, like maybe you didn't go out to seek a few pennies by doing some jobs explicitly, but pretty much everything you've done on social media, things you've done on, say, Google Maps, or pretty much any big website has been used to help them improve their site, and it is in that way a form of crowdsourcing. Have you worked as a crowd worker before? Yeah, that's, this usually wins, so we're actually not. So no is the winner at 40%, but aren't we all just crowd workers, man? It's a close second. Man, it's like having trouble backing up. All right, well maybe we'll just let this work. We were going to do an activity, which we'll do as soon as this manages to upload all of your photos. But I'll go back to the slide presentation. So we got a little bit of a sense, right? So people are interested in this from a bunch of different directions. Maybe people haven't thought about what they have done online as being crowd work before, but maybe I'll change that. Well, I'm not really sure what to take from this because it's a poorly asked question, but most people maybe haven't thought of themselves as doing crowd work before. All right. Anything else? Why are people here? Anyone want to tell me why they're here? Yeah.
I don't know what the course title is. Like, I want to learn more.
Yeah. Cool. All right. So crowd computing. You don't know? That's great. That's great. Well, so I just made that up, but it's a great. I think you'll find that it fits what we're going to talk about. Anything else? Anyone else have a? Yeah.
I recently got interested in like spatial and real-time crowdsourcing, so I thought this would be a good place to learn more about it.
Yeah. So spatial real-time crowdsourcing. So some of the hardest things to do are to get people not just to contribute, but to get people to contribute, say from where you want them to, and when you want them to, quickly. So we'll talk about that for sure. Anything else? Anyone else? Yeah.
I know, maybe just some realistic issues, because like I used to work on some data mining stuff, and I really find it really problematic to have the data labeled. And you said that crowd computing is about something that you have people to have your data source labels and that kind of things. I think it will be helpful. Like you can.
Yeah, and we'll definitely talk about how do you get your data labeled, how do you ensure quality, how do you incentivize people so they do a good job. And this is now powering pretty much, you hear a lot about AI and all the exciting things happening in AI. Well, behind every AI system is data, and all that data has to come from somewhere, and most of it comes from the crowd in some way or another, one crowd or another. All right, so why crowd computing? Let's see. What is crowd computing? We'll see. We've kind of been talking about it. Roughly, it can be this very nebulous term, and the way that I'll use it, and we'll define it in different ways over the course of the semester, is using technology to connect with usually remote people to get something done, right? And this sounds very big and ambiguous and vague, and I think it in some ways is, right? It does connect everything from hiring somebody on the web to label your data for your AI system, all the way to connecting you to a TaskRabbit to help you build your IKEA furniture, and maybe even something that pushes further into what we think of as traditional employment, right? So we're seeing increasingly companies interested in more flexibly working with their employees' schedules, for instance, for good or bad. And so we'll talk about some of those things. I want to talk a little bit about where I got started. I kind of gave you the brief introduction, but I want to kind of dive into that a little bit more to give you the full kind of at least abbreviated history of a project that we've been working on for now almost 10 years. And just give you a little bit of a sense of how it's developed and how some of the themes that we'll talk about here in crowd computing have reflected in this project. So my start was with this application called VizWiz. I've got some slides here that I'll switch to, maybe. All right, so, and we started with really this really simple idea, which is there had been all of this technology that had been developed to let people who were blind kind of sense something about the world around them. We didn't, despite that existing, we didn't really know what people wanted to know about, right? So you might see someone develop this color recognizer, right? So they take in a computer vision class and they apply maybe what they learned in that computer vision class, maybe to something new, cool, and maybe they help a blind person figure out what color something is. Maybe that's useful, maybe it's not. We didn't know. And so we built an application, very simple. It's an iPhone. This is an older iPhone. It was the iPhone 3GS where this first came out. And it did something relatively straightforward. It allowed a blind person to take a picture of something that they'd like to know about, speak a question, and then get an answer back. And instead of trying to answer the questions with computer vision, which has some problems about what it could do, we just sent them out to people. And it turns out we did all this stuff that we'll talk about maybe later to make the answers come back faster. So we got answers back within about 30 seconds from workers recruited from this platform called Mechanical Turk, which you'll become familiar with. And yeah, we did this, we released it, and we kind of saw what people asked about. So in this question, it's which can is the can of corn, I believe. And you can already tell this is a fake question because the picture is aligned really well. If you think about it, it's really hard actually as a blind person to take a picture that's aligned really well. And then speak the question, and then you get some answers, and it says the corn is on the right, etc. But here, let's look at some questions that blind people actually asked with the system. So like I said, we released it. So here's a question. There's no audio, but the main thing in the photo is a thermostat. And so you might imagine they're asking, like, what's the temperature setting right now, maybe. Bunch of different stuff. You kind of see them fly by. This is, how do I cook these? So this is like some package of food. You might say, well, how in the world are you going to answer that question? Well, it turns out that even despite the poor quality photo, if you blow it up, you can see the cooking instructions for this bag of food there. And this is still a really hard, OCR, optical character recognition, right, could maybe eventually allow computer vision to answer this sort of question, but this text is really at the limits of what you might imagine it being able to do, right? It's blurry, it's kind of flipped the wrong way, it's on this bag that has all of these, it's not even, so it's pretty much at the limit, but people can still do it. It's got a lot of questions about how do you cook stuff and that sort of thing. This was a pretty cool one. We got a picture, this is, I guess the lighting is kind of bad here, but this is a picture of a kind of a guy's house, and there's like a yard, and then you can kind of see the sky off in the distances. What does this part of the sky look like? And this was, we weren't really sure what this was about. Somebody asked this question, and then, we were kind of monitoring it pretty closely because we were wanting to see, that it was working well and whatever. And so the same person asked roughly the same question with roughly the same photo every 5 minutes for like an hour, the first week or two that we released this VizWiz project. And we were thinking, wow, if people are just going to ask these meaningless questions, there's no way we're going to be able to support this system, right? I mean, that's 12 questions. I mean, I'll get into the details of this in some class, but we were paying people to answer these questions, right? Let's keep asking these questions over and over again. There's no way we can do it. Well, anyway, after the hour, the user stopped asking the question, and we just happened to notice on Twitter someone hashtagged VizWiz, and they said, I just used VizWiz to watch the sunset, right? So over the hour, the sky did go from light to dark, right? And so kind of watched the sunset with VizWiz, which I thought was kind of a cool thing. And something that we didn't really anticipate. Let's see, what else do we have here? So this is, well, first I'll mention there's a credit card here. We told people your questions are going out to people on the internet that we don't really know too much about. Don't send us private things, don't send us pictures of your face, that sort of thing. People did those sorts of things all the time. And if you think about it, people probably are making this trade-off between, their privacy, especially with this kind of caveat that it's not like somebody they know or who knows them is going to see this image. It's somebody kind of anonymous out there on the internet who might see them, which could be good or bad. And from that, they make this decision. Do they send their private information, their credit card, out to the web and get the answers? I mean, maybe they want to know what their credit card number is so that they can buy something, right? Or do they wait? And so a lot of people made the trade-off to send it out there. So this is an interface panel here. So this is some complicated coffee machine. Turns out they have these at various places. I saw one in Microsoft, for instance. But anyway, someone wants to know what all these controls are, what all the buttons do. And it turns out that this is very common in our data set of VizWiz, people asking these sorts of questions, and also very difficult to answer with just natural language. So I'll get back to that. Let's see, what else do we have? Somebody wants to know if they're clothes match. So it's not just color a lot of times. It's something more nuanced, right? So it's around fashion rather than just what color something is. It turns out we had a whole side project on this, thinking about, well, what crowd would be good for answering this sort of question, right? And people are usually pretty happy to know that it's not me that led that, but someone who probably is a little more fashionable. But anyway, so we had this whole side project on that, and then thinking about, later, could we build the expertise needed to answer a question like this into the system so that maybe people who don't have the knowledge about what is fashionable or what it means, what good fashion is, or maybe not even the same, taste, could help a system answer that. So getting at this idea of crowd computing doesn't have to just be people, but could be people working with machines and thinking about how do you embed the expertise in the machine while having the people do the part that may be hard for the machine, the perception part, for instance. Got that. And anyway, from all of that, we got an interesting sense of what people really wanted to know by putting out this project that was answered by people instead of being limited by the technology that we happen to have on hand. One of the things that we did with that was we put out this data set, right? So a data set that is designed to inspire computer vision researchers to work on this really difficult problem, and yet this really important sort of core problem you would think for computer vision, right? You think about what is more core to computer vision than trying to answer the questions that an intelligent person who just happens not to be able to see would want to know about. So we put this out there. We have a bunch of now papers coming out that are using it to answer all kinds of different questions. There's this cool, completely automated system out by Microsoft called Seeing AI that used it as part of its training data to be able to recognize and answer questions that people had in their lives. One of the things that we did was look at, well, a lot of times we would get questions about certain things, including, as I mentioned before, appliances, right? So it turns out there's a lot of things in the world that just aren't accessible if you can't see them, and you want to use them to do things, right? So you've got copiers and dryers in the coffee machine, and microwave vending machines. One that a lot of people have talked about to us, just complaining about the fact that they can't access are the kiosks or the checkout kiosks, like in a grocery store. You go to the grocery store and you try to use it, but you can't independently enter, say, your PIN number for your debit card. Anyway, so like that sort of thing, or I'm on an 8-hour flight and I know there's this TV entertainment system in front of me, but I can't turn it on to watch a movie or listen to music or whatever. And so we were able to create kind of a hybrid approach where instead of just having the crowd do everything, we had the crowd do something slightly different. They didn't answer a question, but they labeled all the buttons on this interface. And then we used those labels to create a computer vision model that would then allow the phone to recognize those buttons again. So you'd hold the phone back, put your finger on top of a button, and it would tell you what it is. And that would allow you to use a lot of different appliances. And so it's kind of leveraging this idea of the crowd to do the part that's hard, so still generally recognizing buttons and interfaces and all of these different components is still pretty hard. But once you've recognized it for a particular appliance, particular user interface, recognizing it again as something that computer vision can do pretty well. And so kind of marrying these capabilities of the humans and the machines to create a system that would be really difficult to create otherwise. Bunch of stuff here. Here's it working, right? So this is just the computer vision part, but trained on this crowd data. Now, let's see. Well, you can, fortunately, because I've made this video accessible, you can at least see what it is saying, but should be. Try one more. I love where it ends here. So this is a laser cutter. I always think it's pretty cool to see the it end on a blind person using a laser cutter, which some people kind of gasp at, but I think it's pretty awesome. All right, so I don't think the audio is going to work. Oh wait, never mind, it'll work. Let's see the next thing. So then we again took this kind of human computation workflow, which is something we'll talk about, like how do you combine the humans and the machines together. And we changed it up a little bit. So in this case, and this time we added a dollar bill here, and the dollar bill is there because it's something with a lot of detail in it that the computer vision can recognize, and it's of a known size. So it allows us to take these buttons and not just know kind of what they are relative to a person's finger, but the actual size of them. And then we're able to, well, the user takes a photo of it again, and then we're able to automatically, from their photo, create a tactile model that we're able to put on top of it, or a tactile overlay that we're able to put on top of it. And so models kind of automatically created, again, working with the crowd to label the buttons, the user to take the picture of the interface, and then the computer figures out how to create the tactile overlay from that. There's tactile overlay, here's it being printed, and then here's the user lining that and then ultimately using it. Turn those lights off. So just an example kind of where we started with this pretty straightforward crowdsourcing system. We use that to understand a domain, create data. A lot of people are using crowds to create data to then train AI systems and also figure out what people wanted to know and then how we can combine what the machines are able to do, the crowds are able to do in order to create an application that wouldn't have been possible before. And that's roughly what this class is about, those various steps along the way, right? So depending on what your interests are, you may be most interested in labeling data, right? Like you might have a bunch of data and you want to label it so that you can work on the machine learning algorithm that's going to be able to predict from that data how to label new instances. You may be interested in the part that is kind of encouraging people out on the web to work together towards some aim, to power some system, to accomplish some goal. You might be interested in this kind of human computation aspect of it, where it's not just people and it's not just the machine kind of offline learning from data, but it's the machine and the people and the user all working together to do something that we couldn't have done before. And so we'll cover all of those different aspects in different ways. Let's see. Go ahead and close this. Get back to my other presentation. Actually, I'm going to check my phone to see if our pictures are uploaded. I'm going to check one more time, just looking at my photos to see if they're there. Oh, they are there. Okay. So another kind of class activity is an example of what we can do with the power of the crowd that's in this room. We are going to, I'm going to take these photos really quickly here. Copy image. Okay, where'd it go? Okay, class photo. All right, I'll place that one in. Take this one at the middle. You're going to be immortalized as doing that, which is great. Okay, so there that is. Drag this over until it's roughly, oh, wait a second, there's two. Anybody cut off if I do this? Yeah, right there, somewhere like right there. Anybody cut off? Can you, if you're in that scene, can you see yourself? Yeah, all right. And then we'll have our last photo here. Okay, drag this like way over here. Let's see, where is, okay, so probably there, something like that, all right? Okay, anybody cut off here? Yeah, you're all still in the photo? All right, I think that'll come back, let's see. Hope that didn't all go away. What? That's very weird. Okay, I'm gonna have to do it again. Do it again. We'll see. Okay. All right, so I'm going to take this. I've already shared it, I think. So I'm going to take this, go to Shout Key, so you can see the whole process. Now, before I do this, okay, here's the kind of process we'll go through. So the goal is to, as quickly as possible, put a little label above or by or whatever each person's head, so that their name is there. And the only rule is you're not allowed to label yourself. Okay, so I'll start a timer. We'll see how quickly you can do it. It's kind of hard, right? Because there's a little bit of coordination. You got to talk to each other. You're probably gonna inevitably people will start trying to drag their labels around or whatever, and the photos will get erased or something. So yes, I have a timer. Or no, stopwatch. All right, so. Here we go. I am not a robot. I'm going to shout it. Are you ready? Well, once you get there, though, you'll be. Yeah, just the shout key will expire. But all right, shoutkey.com/salsify. Salsify. Salsa. What is that? They're getting really desperate. They're getting too popular. They have all these words that don't. All right, so here we go. There's very little activity. Oh, there's a bunch of people, though. All right, we're getting close. Getting close. All right, we're getting there. We're getting there. We just moved the photo. So wait. Yes? Yes. You have a person there? Yeah. All right, is somebody working on the people who do not have names? We've got. Wait, is Stephanie? Wait. Oh, Stephanie's you. Oh, okay. Oh, okay. All right, so we're getting close. We're getting close.
I don't need one of these. I don't know who else made the second name tag. Is someone else named Karen?
Somebody working on your name? Somebody is? Okay. We're almost there. We're almost there, I think. Right? No?
Yeah, that counts.
Hold on. You can't do yourself.
This is great. All right, I think we're pretty good. Yeah, are we good? Something close?
Beautiful.
Beautiful. All right, you're all about ready to get locked out. 3, 2, 1. Actually, no, you can still view, I think. But all right. So, any comments about what just happened? Did you see? Did anyone? Was everyone just heads down, like trying to label names, or did you see what was going on as we were labeling names?
Well, at one point, like the middle picture shifted. So
Yeah, the middle picture shifted. Who shifted the picture? Anyone? You know what I miss? You know, it's interesting when I do this in class. Very few big problems happen. I think people are, even despite the fact that it's anonymous, right? You're all like anonymous giraffe or whatever. Very few people try to mess it up, which is interesting, I think, because it's not necessarily what you see on the internet. But you know, there's some, I guess, accountability because we're all in this room together, and you know, you're presumably here because you want this to work. Anything else people noticed? Yeah, Robert.
Formatting's all different.
Formatting's all different. Yeah, people had different kind of ways of labeling. Yeah.
Even though the formatting's different, like once the visual style was like defined, other people copied it.
Yeah, there was almost like this meme of the white background, right? Spreading out through the crowd. That was pretty cool. Anything else?
And there's some noise.
There's noise. Oh yeah, is anyone incorrectly labeled?
I mean, some non-related stuff, like projectors, stuff.
Oh, screen. Well, so Felicia and Patrick are presumably the people who walked in a little bit late after the photos were taken. And so yeah, but people innovated, right? This is innovation. This is great. Anything else? Well, it's kind of a silly example, but a lot of the things that we saw here we'll see in other crowdsourcing systems or crowd computing systems. Issues of expertise, right? So one thing that is interesting about this is because I said you couldn't label yourself, people around you, this local expertise of people around you, or maybe if you knew people from other classes or things, had to be the ones that labeled you. So finding that expertise or kind of getting that expertise to the people who could actually do the work was interesting. This idea of maybe people coming along and trying to mess it up, even if it was an accident. In this case, that will come up. The memes, right? So the idea that sort of you're all working on your own tasks, but you're not, right? Like you're seeing the collective result, and that influences your behavior, even if it's something small like the style of the text. And yeah, and you know, the crowd sometimes wants to have fun, and so you know, the screen is labeled or the projector is labeled. You know, all these great things that happen if you have a system like this, where people don't necessarily want to play by, you know, just the base set of rules, right? They want to have fun. They want to innovate. And when I didn't even stop the timer. Anyway, I don't know what the prior classes who have had do this activities time was, but I'm sure you're the best. So, great. All right. There's my start. So now I just want to go through some projects. The rest of the class is basically going to be some projects that illustrate some more of the themes that we'll cover throughout the class. And then we'll spend probably the last 10 minutes or so, 15 minutes, kind of going over kind of logistics, right? So what can you expect in this course, and you know what will you be doing? All right. So most people that I run into first exposure to crowdsourcing is in data collection, right? So many people have started with the idea of how do I get data to do X, right? Some AI problem generally. And maybe that's because I hang out with a lot of computer scientists, but anyway, it's a very popular use for crowdsourcing. One of the first approaches for doing this was invented right here in Carnegie Mellon by Louis Van Ahn and Laura Davish. And it was with this relatively simple game that they created. It's called the ESP game, and the idea was that people out on the web would come to this game, and the way that they would do well in the game, the way they'd get points in the game, was they'd each be shown the same picture. They'd have no way to communicate. They had no idea who each other were. And they were asked to provide a label for that image. And what made it work well was that because they had no other way to communicate, to get points, they had to enter the same label. If they agreed, they got points. If they didn't, they didn't get points. And so their best strategy was to enter labels that were actually in the photo, right? So if I said, potato, I'm unlikely to agree with my randomly chosen partner out on the web because there's no reason to particularly say potato. But if I say, face, I would probably be likely to agree, right? And that's a way to start building up high-quality labels for images that could be used to train computer vision, or eventually Google bought this, turned it into the Google Image Labeler, and they used it to help power their image search, right? So if you got a bunch of images you found on the web, people want to search for them. How do you do that? Well, one way is to collect labels using a game like this. And computer vision has really taken off with this idea of crowdsourcing. So there's a whole bunch of different applications now that use crowdsourcing to get different kinds of labels that are used to train computer vision systems. So another popular system is called LabelMe. And in LabelMe, they take it one step farther where they're not just labeling or not just providing text labels, but actually outlining little areas on the photos that are provided so that computer vision can start to learn these various objects, so like windows or cars or trees or whatever else. It's also been used to help science. So Galaxy Zoo now has a whole plethora of different kinds of projects, but they started out with a relatively simple, classify this galaxy, and you would say things like, is this a smooth or, I guess, rough galaxy? Is it a spinny shape, etc.? Things that the scientists could use to help understand what's going on in space. And people, in this case, they weren't paid, and it wasn't really, they sort of had some gamification aspects to it, but really people did this because they liked the idea of contributing to science, right? So by doing this as a person on my computer at home, I can help kind of further science, and people like that. Maybe they like learning a little bit about galaxies as they did it. A recent data set that came out called Visual Question Answering, so VQA, kind of twisted this around again where they took pictures from the web and they asked crowd workers, in this case it was paid crowd workers, to propose a question that could be answered in the photo and then answer it. So things like, here's like a playground scene, how many balls are there? Or here's a plate of food, how many pickles are on the plate? Or has this pizza been baked? So really getting into these kind of hard to answer questions if you think about it. And they had paid crowd workers do this. And they were able to produce this data set that's now computer vision researchers are competing to see who can do the best job at answering this. It's really pushing the field forward because of that. It's interesting, you know, it wasn't too long ago that computer vision researchers would have found this kind of a task way too hard to even try. And there's many different simultaneous themes of things that are happening right now that are making them more confident in being able to do this sort of thing. One of those things is developments like deep learning, which is allowing for much better computer vision systems. The other kinds of things that are happening are increasing data sets, right? And these two things have to go hand in hand to have the computer vision researchers make progress on this sort of stuff. So that's all data labeling, and I guess all those examples are from computer vision, which I find pretty interesting. Similar things are happening in all kinds of different other tasks, right? So a lot of natural language tasks, speech recognition, other really hardcore AI problems are benefiting from data sets that are collected with the crowd label, very similar kinds of mechanisms. But that's still not really, you know, crowds. You think about crowds, think about like lots of people, right? Maybe like people working together, like people coming and going. I don't know, all these different things. So far, we've not really seen too much of that, right? We've seen people coming and they're providing labels, not too different than what you could have had, say, hired people to do in the past. That used to be what people would do. They'd hire kind of local people to label, provide labeled data. Maybe we can get access to more people, but you know, what's really changing? And so one of the things that I think is interesting about crowdsourcing and what's different than just hiring people as it always had been, is people working together, right? And so if I take this is the definition of crowdsourcing. Crowdsourcing is the act of outsourcing tasks traditionally performed by an employee or contractor to an undefined large group of people or community, a crowd, through an open call. I like this definition because it actually came from Wikipedia, which is a crowdsourced encyclopedia, right? So completely different kind of thing, sort of, right? But still benefiting from this idea of people out on the web brought to do a task, kind of work together, and it has all these fascinating implications, right? So how do they choose to work together? How do you guarantee quality? And they have completely different mechanisms than what a lot of the data labeling approaches have had. But this definition is an interesting one, right? The act of outsourcing tasks traditionally performed by an employee or contractor. So certainly the data labeling has that aspect, right? We definitely, in computer science, used to hire local people, largely undergraduate research assistants, to come in and just label data, right? And now a lot of that's been pushed to these flexible, kind of on-demand remote crowds. To an undefined large group of people or community through an open call. And that open call, we'll see through the course, the open call is pretty important. So the open call means I don't necessarily know when I put out a job who's going to respond, right? So, and because I don't know who's going to respond, I don't know much about them necessarily, right? So I don't necessarily know what they're good at, how good of a job they're going to do, et cetera. And so a lot of the work has been put into kind of understanding, you know, what are they good at? You know, did they do a good job? Should I keep giving work to that person, et cetera? So here's some other kind of interesting systems that show kind of people working together. So this is a system called Turkit. It's by Greg Little and some other people back in, I think, 2009-ish. And what they did was essentially explore the effect of having multiple people kind of take a stab at a problem in sequence. And so here's an example of what they were able to do. So this is a little bit of text that was scrawled by Greg. He says he used his left hand, and he was usually right-handed, and he used his left hand, and he purposely tried to make it messy on top of that, right? Can anyone read this?
No.
Yeah? Oh. All right, so it's hard to read, right? Sure. So what they did, or what he did, was use a crowdsourced workflow, and I'll show you what that looked like, but they were able to recover this pretty well. So you misspelled several words. Please spell check your work next time. I also noticed a few grammatical mistakes. Overall, your writing style is a bit too, and these pink words are the ones they got wrong. But instead of phony, it was supposed to be flowery. And you do make some good points, but they got lost amidst the writing. Not sure what that was supposed to be. And then signature was actually B-. This was like a little. Have you ever gotten work back from like a professor and like it's like you can't read it? Yeah. So that's what they were trying to solve. Anyway, so how did that work? Well, it just proceeded iteratively, and so they showed it to one worker, and they said, this is really hard to read, so you're not going to be able to read everything, but just try your best. And if you can't read something, if you really don't know what it is, but you know there's a word there, just put a parentheses and a question mark. If you have a guess at it, instead of a question mark, put your guess in the parentheses, right? And so the first worker came along, and they didn't really do a very good job. But they got some of the stuff, right? Or I guess I was at the beginning, they didn't do a good job. I think they got a bunch of stuff. And then like more and more workers came along, they kind of refined, and by the end, they got out this pretty reasonable interpretation, much better than probably most of us sitting in this room thought we would have been able to recover from this really messy text. And so it's kind of this power of having multiple eyes on it. Nikki Kidder here at CMU used kind of a similar kind of approach, but used more of a MapReduce kind of style to break down a big task like writing an essay. And so in this case, the crowd workers didn't all see the same thing in sequence, but instead had kind of different jobs at different points in the workflow where the first set of workers kind of came up with an outline. So if I wanted to write an essay about what I should do in New York City, well, I can come up with an outline, like what's kind of stuff I should probably do, like attractions, a brief history of New York City, etc. And then I can have other workers come along and say, well, for attractions, like what are the main attractions? And so each worker came along and added a fact, right? Like maybe you want to go to the Empire State Building. And then you had another set of workers reduce or kind of combine those different facts into a paragraph, right? And then once you combine all those paragraphs, you've got this essay. And so it's taking this kind of big task of writing an essay and kind of decomposing it into these little micro tasks, right? And then figuring out how to combine them back together. So no worker has to do a lot, and potentially you benefit from the kind of collective wisdom or the collective experience of a lot of different people. Another project here, Seth Cooper is at the University of Washington. Adrian Troy was faculty here during the release of Fold It. And so Fold It was a game that was put out. And the idea was that there's this really hard problem in computational biology, which is kind of figuring out how proteins fold. And if you can figure out how they fold, it has all these implications for like developing drugs for things, like doing genetic tests, all this different stuff. But computationally, it's very hard to figure out kind of how these different things fold into different shapes or whether they can. And so they created a game that took the protein, allowed people to kind of manipulate it with like game mechanics of moving it around. And they released it out on the web, and it turned out that these players out on the web who didn't have any particular credentials in biology were able to make a number of scientific discoveries that by playing this game, right? And there's all these things that happened as they did this, right? So the players that really contributed the most to this problem, they built up a bunch of expertise. It was kind of at this intersection of this particular game instantiation and then biology at the same time. But they were able to do these things, and they had a number of papers that appeared in places like Science and Nature about not only the process of doing this, but actually some of the discoveries that they found from doing it. So it's kind of cool, like bringing in people that don't necessarily have the expertise or maybe not the expertise that we traditionally think of being needed to solve a problem, and via their kind of accumulated work, get out a really interesting thing, like a scientific result that would be worthy of publishing in Nature. Aaron Koblin is an artist who's done this really fascinating collection of work where he's had the crowd kind of collectively contribute to art projects. So this is just one of them. There's a whole bunch of them. I encourage you to just Google his name. He's got most of them online, and many of them are interactive. But here's one where he just had, he had like 10,000 people. Yeah, 10,000 people draw a leftward facing sheep. And it's super cool. I think it's super cool because all these people with varying levels of ability and different interpretation, drew a sheep here, and it's fascinating to look at him. Anyway, but if you look, there's all kinds of great examples. You had people come and they each sang like a little part of a song. I think it was like, was it something about where my dog went or something? I forget. Anyway, these classic songs. And then he computationally like stitched them together and like sort of tune match them so that they would be kind of a choir after the fact, you know? And so anyway, very cool stuff. So again, how can people collaborate in remote distances? And you know, I think this sort of thing is really interesting. Another example, this is Krzysztof Gajos at Harvard had this system where he's trying to help people who kind of want to track their nutrition intake, but it's kind of hard to, you know, figure out all the things you've eaten, and especially if you're at a restaurant or something else, you know, it's really hard. And so he came up with a system where you would take a picture of the plate of food that you were eating, and then the crowd and a bit of computational support would tell you kind of the nutritional information for that plate of food. And so the crowd is probably best skilled at things like identifying that this is corn and this is, I don't know, some kind of steak or something, and kind of saying maybe what the relative size of that is. And then the system would go off and it would say, well, you've got this much corn, and so I can look up in some sort of table, you know, what that much corn has in it, you know, what kind of nutritional information it has, and then kind of combine it all into, you know, your overall, if you ate that whole plate of food, what you would have consumed. And the cool thing about it is that, well, nutritionists aren't actually very good at this. It's really hard to know all these things and have them on top of your head and all that. But the system was able to do better than the nutritionists in accurately labeling the nutrition information for a plate of food, which might have interesting implications for people who want to watch that. So that's just kind of, again, examples of people working together, maybe in concert with machines or not, to do something that's really difficult for any individual to do. Another thing that we've been looking at is what we call kind of crowd power systems. And this is systems that have the crowd interactively working with the user, systems that kind of understand, that react, that respond in ways that we might want our AI systems to eventually, right? So increasingly we see examples of these really interesting but still limited AI systems in our everyday world, right? So we see now Echoes and Google Homes that you can talk to, and they can, you know, say things back, but you can't just say anything you want to these systems, right? They are still pretty limited. We see speech recognition systems that work pretty well, but, you know, as soon as you're a non-native speaker, or you're in a noisy room, or you're too far from the microwave, or whatever it is, microphone, you know, they don't work very well anymore. And so how can we put people into these systems to make them work better? Here's an example. This is a fun one. It's by Michael Bernstein, who's now at Stanford, and he imagined putting the crowd into your document editor, so that you could do all those things that you don't really want to do, but yet can't yet offload to the machine. So things like do a really careful editing pass. Things like, well, you know, this paper is currently 2 pages and, you know, a paragraph, but, you know, the professor said it could only be 2 pages. And so have the crowd go off and shorten it for you. Also interesting implications for what that means for, you know, the academic honesty policies of different things, right? So if you wrote the whole thing, but then the crowd shortened it, is that okay? I don't know. But so here's a video about how that works, I think.
Soylent is people. It explores what's possible when we start embedding humans, paid crowd workers, into our interfaces. Soylent is an add-in for Microsoft Word that gets human help to support tasks that Word can't do well: shortening, proofreading, and open-ended editing via macros. It does this by recruiting workers on Amazon's Mechanical Turk service to solve hard AI problems for just a few cents. Each member of the crowd does a little bit of work, so it's like having tens or hundreds of people help you write your document. One of Soylent's features is called Shorten. Shorten helps writers cut down their text. It's tough to trim a document to meet a size limit, it takes time, and it's hard to look objectively at your own writing. Shorten asks Mechanical Turk workers to find parts of the document that can be cut down without changing your meaning, and then offer a few rewrites. Its interface gives you direct control over the length of the text. Drag the slider to specify the length you want for your paragraph, and Shorten combines the lengths to match. We've shortened text ranging from blogs, academic papers, and rambling emails, and we got cuts down to about 85% of the input each time. We paid workers about $1.50 per paragraph. You can pay less, but you'll wait longer for workers to pick up your tasks since they're less lucrative. We got it down to about 30 cents. Crowdproof is a distributed human proofreading service. Microsoft Word misses all sorts of obvious grammar errors that humans can catch. Crowdproof finds these errors, explains in plain English what the problem is, and offers anywhere from 1 to 5 rewrites. We've used Crowdproof to clean up text like non-native English writing, bad Wikipedia pages, and paragraphs full of errors that Word can't find. Word finds about 30% of the errors in these texts, Crowdproof finds about 2/3 of them, and fixes about 90% of the errors it finds. Last is the human macro, a natural language crowd scripting interface. Usually users would need to translate their ideas into code, which is tough. Instead, the human macro lets you automate complex actions by describing what you want naturally, in words. Launching the human macro opens a request form where you can write what you want, like you would a Craigslist post. Our goal here is to keep users from launching buggy commands. So we show a live preview of what the request will look like and let the user do a test run on a single paragraph or sentence. So our users have gotten the human macro to transform a short story from past tense to present tense, to find creative commons licensed images to describe a paragraph, and to flesh out citation sketches into a real references section.
So yeah, so think about the next time you're writing an essay, wouldn't it be great to have people writing your interface? And I talked to Michael. I think he does know that Soylent is people. It does have another connotation, but another thing we've worked on is speech recognition with the crowd. So one of the tasks we were trying to support is captioning, live captioning for a class like this or a lecture. Which is really hard because there's these various constraints that you need to work within. So one of them is the speech to text has to happen pretty quickly, so less than 5 seconds. Even a small number of errors can be pretty confusing, right? Imagine if even 1 out of 20 words that, maybe not me, because I'm kind of telling you about these really cool applications so far, but imagine you're in one of your really hard math classes and 1 out of every 20 words was something that didn't at all fit, right? Here it's telling you about some integral you need to solve, and then potato, and then how do you recover from that, especially if it keeps happening. Anyway, so we had people do it, and at first we did not use speech recognition technology, but rather streamed the audio to remote workers recruited from sites like Mechanical Turk, where they would type what they heard. Unfortunately, if you're not an expert stenographer, you can't type everything. It just goes by too fast. Natural speaking rates are anywhere between 180, 300 in bursts words per minute. And so we changed it up where we had multiple people, and they each typed part of what they heard. But then you have this other problem where you have these random kind of snippets of what's being said. And so we developed an algorithm that stitched those back together. And so it's not just people, but it's people working together with the coordination of a machine that then is able to stitch those pieces back together and send them back to the user in about 3 or 4 seconds average word latency, which is pretty good, and it works, as you might expect, a lot better than speech recognition in a lot of cases because of those problems I mentioned, where the speaker can't be heard very well, the speech system doesn't work fast enough, using words that aren't in the dictionary, etc. One of the things I really love about the conversational assistants that are out there now is that they are not conversational. And so while they're really cool, I have an Alexa, I use Siri, I use all these things. They're mostly speech command driven, right? Where once you've learned what they can do, you can speak to them and give them commands. And so one way to illustrate that is I have this book that I saw in the Squirrel Hill Library, and it's a book called Talking to Siri, and it's about that thick, and this was a couple years ago, so probably now it's about that thick, right? Like all the things that Siri can understand. But the idea here is that users are training themselves to be able to be understood by Siri and training themselves to understand what Siri is capable of doing. And so we thought, well, how can we change that around? Like, wouldn't it be great if you could talk to Siri about anything you want, and not just talk to them in a single, utterance and response, but have a conversation, right? So conversation is about kind of building a shared context, right, where the system learns about you over time. You're able to, as the system learns about you, use that context, that shared context, to communicate more efficiently. And so we created a crowd-powered version of this, and we're able to have conversations about pretty much anything. Here's a sample of conversation. So requester, which is the user, says, "Hi, how are you?" And it's kind of backwards. This is the crowd. This is the crowd's responses. We have multiple people who come here. They all are suggesting things that might be a good response to "Hi, how are you?" And one says, "I am fine, but wondering if we can do this more than once." Another says, "Does anyone know if we can? How is everyone doing? Are there any questions? Are we the only ones here?" Then someone comes along, says a really good response. Says, "I'm good. How about you?" What time is it there, etc. Anyway, so with a very simple workflow here, the crowd suggests responses, and other crowd workers vote through the ones that they think are good, and we're able to take something like this, turn it into "I'm good, how about you?" And then continue on and have a whole conversation with the user. In this case, they're interested in getting some food in LA. They want to know, what's available, what's a good restaurant they might want to go to, how to get there from where they are. And I'll go into this more in future classes, but we've been able to do a lot of really interesting things with this. So the idea that people out on the web can collectively help you figure out and work with a problem. And if you're on the go, we now have this. Actually, I think I have the next slide. We kind of updated this over the years. It now works with Google Hangouts, and so I encourage you to try it. You can go to talkingtothecrowd.org, and you can talk to crowd workers on Amazon Mechanical Turk about whatever you want, and we'll see what your experiences are like. We drove robots with the crowd. So we had this little robot.
We present Legion, a system for real-time control of existing interfaces by the crowd. To use Legion, users first select a portion of their desktop interface that they would like the crowd to control, provide a natural language description of the task for the crowd to perform, and offer a price that they are willing to pay. Legion then forwards a video feed of the interface to the crowd and forwards key presses and mouse clicks made by the crowd back to the interface. The worker interface displays the video feed and collects input. The input of multiple workers is mediated by various strategies described in our paper, allowing multiple workers to effectively control a single existing interface.
So I'll stop it there. The cool thing about this is we had this little robot, right, in our lab, and we had multiple people recruited from Mechanical Turk again, and we're having them drive this robot, around our lab, and they all could contribute commands, and there was different ways, you can imagine some obvious ones like voting, whatever, where, we chose which of the commands were going to be sent to the robot. Here's the worker interface, right? So they're just trying to hit that teapot, which is actually really easy, but because of various reasons, it wasn't. One reason was that some crowd workers would just leave, right? So they'd kind of be contributing, but we need to bring new ones in. Another is, it could be really slow if you really had to take a vote on each step of moving that robot. And so we had to come up with more interesting strategies. We did all kinds of things. We were filling out spreadsheets, other things where it's kind of like a remote desktop interface to the crowd. All right, so we'll continue with some other examples on Wednesday, but I want to get to some logistics of the course, right? So I'm going to skip down to here. So when we think about crowd computing, programming the crowd, there's a lot of really interesting problems, right? And these come from both the technical side, the theoretical side, the human-computer interaction side. And so how do we choose a right crowd? How do we break down the tasks that we're going to have crowd workers do appropriately so that they can do them? How do we build systems that allow us to interact with the crowds from programs that are easy to use and that fit with programming paradigms? How do we incentivize workers to have quality work, to do things quickly if we want that? How do we make sense of the work that they do to know if they did a good job, right? So if we accept the idea that some workers are not going to do a good job, we need to be able to somehow differentiate those who are doing a good job and those who aren't. How do we kind of choose good problems for this kind of approach? And how do we make crowd work more beneficial to workers, right? So, one of the interesting things for me is that to see this field to mature over the last 10 years or so is that when this first came out, people were just really excited that they could get data. I mean, really, that was the thing that drove it. And then now we're doing more and more interesting things. There's all these connections to kind of the future of work, where if we think that this kind of work is going to be more common, this kind of flexible nature, where people who have work for someone to do are able to call upon the crowd flexibly. I mean, that sounds pretty exciting if you're the person that's offering the work, but if you're the person doing the work, that's maybe not as exciting, right? Where you might wonder about what kind of wage am I going to get paid? Do I have any kind of sense of stability, right? Like, what's my ability to kind of skill up over time, right? In a traditional career, you're able to kind of learn on the job, to do things like you might be able to advance through, a corporate ladder toward maybe more interesting, more managerial positions. What would that look like in the scope of the crowd? And so there's all these really interesting questions that we can answer. And the course will touch on all of these different topics. But I wanted to distill this down, right? So what will you actually learn to do in this class? So one of the things is I think that you'll learn a lot about kind of this concept of crowdsourcing, right? And related ideas. So there's a lot of different things that are all kind of embedded in this notion of crowdsourcing. And so I'm going to introduce a lot of the terminology, and you're going to get to kind of interact with a lot of different types of crowdsourcing, what that means. You're going to understand what it's like from the worker perspective, right? And I think that's going to be really beneficial for going forward and building systems or interacting with the crowd. And you're going to actually build applications that collect crowd data, make sense of it, make sure it's high quality, and interfaces systems that power themselves with the crowd. You can find out more about that. There's a web page here. It's called programthecrowd.com. So this is our web page. There's a whole bunch of information here. Programthecrowd.com. The course description. Go through. I'm going to go to the grading here because it kind of tells you about various things that you will do. All right. So there's 4 main components of the actual work that you'll do. One is projects. So we have somewhere around 5 or 6, 8 projects. Okay, 8 projects. And these are due every week or two during the first, say, 8 weeks of the course. So the beginning of the course, every week or two you'll have a project. They're not intended to be a tremendous amount of work, but they are designed to kind of introduce you to different technologies, different things related to crowdsourcing. So you'll see the first one is already up under projects. It's not due for 2 weeks, but the first one is a fun assignment. I really like it, which is being a crowd worker. So you're going to sign up for Mechanical Turk. You're going to earn $2 on Mechanical Turk. Don't spend it all in one place. And hopefully that will be a good introduction to kind of all of the messiness and interestingness around that particular platform, but crowdsourcing in general. Other projects are more building oriented, collecting data with the crowd, making sense of data with the crowd, building interfaces that are powered by the crowd, etc. So that's the projects. Readings, every day of class, there are between 1 and 3 readings, and I'll ask you to read them. And mostly that's I trust you to read them, but there'll be a slide deck posted, and I'll ask you to write 1 slide with something about the readings that you read. Something you found interesting, some insight you have, and that will be due before class. So you make 1 slide about 1 reading and add them to the collective slide deck. We might go through, spin through those at the beginning of class just to see kind of what's up there. Final project. One of the most exciting things, at least in the past years, has been the final project, where students, you can propose your own project. This year is a little bit different in that the theme is around the worker side of things, right? So in the past, people have built projects around, well, what can I do with the crowd? Well, in this year, we're going to focus more on what can I do to help benefit crowd workers, and that is also a very big problem space. Lots of different things you could do with that. I have some final project ideas here. Things like, it turns out that one of the difficulties of being a crowd worker is finding work that's good to do, and so somehow no one's really done much work in building systems that recommend good tasks to crowd workers. So you could build something like that, or you could design something that a new way of finding work for workers. You could automate some of the repetitive things that workers do. You could, build surveys. A lot of people do surveys online, and they end up spending time entering kind of redundant information from survey to survey, like their name, demographics, other things like that. Could you build something that helps kind of make that more efficient? Could you use, maybe you've taken an AI class, or maybe you know a little bit about, say, computer vision or speech recognition or something like that. Could you figure out a way or explore a way that some of that technology could be used to augment the crowd workers, right? So many crowd workers you could see as kind of working to put themselves out of a job, right? So if you train the speech recognition system long enough with the crowd work, then maybe eventually you won't need the crowd workers. But you could also see it as, well, can we really explore this idea, which seems actually much more beneficial, but also more likely to happen, where the crowd workers or people in general will be not necessarily replaced by AI, but working alongside AI. And so we have an opportunity, I think, with some of the crowd work platforms to right now experience some of the benefit and explore how that might work by, say, pairing up crowd workers with AI and maybe making them faster, maybe making them more efficient, etc. So there's a lot of things like that, and I think there's a whole bunch of other things that you could do. I mean, if you're more interested in, say, understanding the worker experience, I think there's a whole bunch of still open questions there. There's a lot that's actually happened, but I think there's a lot more that could be done. If you're interested in exploring, say, how would you engage a different kind of crowd, different set of workers, I think there's a lot that can be done there. I just read a paper by Robin Brewer from Northwestern. She was working with older adults that were retired, but were interested in kind of being connected to some kind of profession, work. It was exploring how Mechanical Turk would maybe serve that kind of role. We've been thinking a lot about how you could bring crowd work into kind of rural areas, especially around Pittsburgh, where maybe the employment isn't as available as it used to be. And so there's a lot of different things you could do with this theme, but kind of focusing on that worker side this year. If I go back, back to the grading, I'll get to the. Okay, so final project, mini quizzes. We're gonna have a little quiz at the beginning of every class. You can miss some of them. There's details here, but the idea is, just to encourage you to read the readings and attend the class. It can be pulled from lectures or from the readings. Usually they're pretty simple. And extras, there'll be numerous opportunities to earn additional points. So I didn't go into the points thing. So because we're kind of a crowdsourcing course, and a lot of times, people add points to things or gamify things, we are going to reinterpret the grades as points, and you can level up. You're all starting out as the noob crowd worker here, but don't worry, your crowd expertise will quickly grow, and you will get to discover all the different levels that are behind these silhouettes. And so everything's measured in points. In the end, it gets interpreted basically just like these were grades. But I think it's interesting to kind of live through this, because many people's first reaction to crowd work is, oh, let's gamify it. Everyone will just do things for free then. And kind of living through that idea of, what does it mean when you're measured with points is, I think, pretty interesting. So we'll try it. You can see what the point totals are here, and you can work out, what the respective percentages of each component of the grade is. In the end, I think, well, you see the totals here, and your grade will just be determined by dividing the total possible points. So it really is just a percentage, but cast in a slightly different way. Have anything else? Oh, check out the schedule. Schedule is subject to change further down a little bit, but you can get a really good sense of the various things that we will cover. It's more or less completely filled out. And projects. These will probably be very similar, but I just wanted to warn you, maybe don't go working ahead too much. The only one that is set is this being a crowd worker. And I'm being easy on you a little bit in that one of our readings you'll see pretty early on is, I worked on Mechanical Turk, and I think I earned like $10 over the. Now I think I'm up to about $100, but my experience as a crowd worker, I think in 4 hours I earned maybe $9 or something. So $2 isn't that much time, but it's enough time to really get you a sense of maybe some of the problems. It's always great. You shouldn't. Every problem that you will have doing this probably has happened before. Like people have had their work rejected. They've not been able to sign up because there's all this onerous little process that Amazon makes some people go through. All these things. Take that all with spirit of learning. But it's a lot of fun. And I think that's all I have for today. Does anyone have any questions? Yeah.
For the readings, are the goal that we know everything that you're saying, or is it just get the general gist?
Get the general gist. I'm not going to ask you any detailed questions. I'm not going to ask you any really specific questions. It's more kind of just what the gist is, what's the high level. Yeah.
Do you post your slides online? Should we?
Yeah. So the slides are all in this Google Drive folder here, and so they will be there. You'll even, if you really wanted to, you could even see me work to write them and update them before class. Yeah.
I'm not too familiar with computer vision, but since we are in the field, I thought I'd ask, seeing some companies starting to build out teams like Tinder is building out a computer vision team, and I'm curious.
Why did they do it?
Well, I'm curious why certain companies would be getting into that, or I don't know, because I don't have the context to know what kind of problems they would solve with that.
Yeah, well, so Tinder, I'm not sure why Tinder in particular. I know Snap also has a computer vision team. I think any company who has large amounts of image data, as Tinder would, is probably trying to understand more about that data automatically, because they have too much probably for them to really in a scalable way look at all of the images themselves.
Okay.
Everything. So what they're doing, I don't know, but companies in general will use computer vision and crowdsourcing to do everything from identify inappropriate images, right? So Facebook, well, actually all the social media team companies have huge amounts of people assisted by computer vision who are making sure that there's no inappropriate stuff. And defining what inappropriate is kind of hard, but at least on some edge of it, they can identify it. The other things would be, I don't know, people are looking at everything could you with computer vision give people who are posting a profile on Tinder feedback about whether or not that their photo is the best representation of them as it could be, or I don't know.
Yeah,
I don't know what else they're doing, but all those things, anything in between, right?
Yeah. Okay. Cool.
All right, great. Okay, last question, and then anyone else wants to talk to me, I'll stay around.
Just to make sure, for undergrads, on your grading, you had plus and minuses. There's no plus and minus on undergrads.
Right. Yes, that's true. So if you are anywhere from a B- to a B+, you will get a B. It is tricky. It's really hard to know because the different programs all have different rules about what grades are possible. And so the time that I actually know what grades are possible is when I go to enter your grade into the online system, and it gives me an error that says that grade is not possible, and so then I always round up. All right, thanks a lot.